I am Thevan Raj, currently pursuing Mechanical Engineering Semester 4. This is a video I have done on our project, the wind noise reduction sunglasses. Wind noise can actually be very loud, annoying, and exhausting. The occurrence of wind resistance doesn't only limit the potential of a cyclist, but also is known to cause hearing disorders in which prolonged exposure eventually leads to hearing impairment. Limiting hearing capabilities during cycling and hearing disorders are the focal impacts on the cyclist due to this phenomena. Recent history has communicated reports indicating how cyclists encounter hearing problems such as the tinnitus, postulating that these problems are induced due to prolonged exposure to wind noise. In a position where a cyclist keeps his head straight, where both pinnae are exposed to the point of flow of separation of the wind noise largely affects both the ears, causing such injuries to occur. An average person encountering a 21 mile per hour wind comes in contact with noise within the range of 25 to 150 Hz at an intensity of 92 decibels above the quiet hearing range. Therefore, it is safe to say that the hearing damage is proportional to both noise intensity and the duration of impact, as 92 decibels is above the Health and Safety Executive daily exposure limit. This has proven to be a vital hazard and often is the cause to most accidents which has occurred during cycling on the roads. In general, the unnoticed dangers are behind a cyclist, known to be a blind spot. A cyclist might hear a car when it's a mile away under quiet conditions, but are often startled by these vehicles overtaking them, even other cyclists for that matter. Various solutions have been discovered to overcome this problem, such as attaching a wind noise reducer on the strap of the helmet. Based on surveys done and cyclist forums on the internet, it can be seen that the users are finding difficulties and discomfort in wearing the wind noise reducer on the strap of the helmet, as it comes off as a little annoyance after a certain speed. Therefore, this has inspired us to design the wind noise reduction spectacles to redefine the mechanism of wind noise reduction. The wind noise reduction spectacles is a multifunctional and stylish option to stay safe while on the road. There are a few objectives that have been targeted in carrying out this project. The main objective of this project is to provide protection to the auricle of the cyclist, thus reducing the damage caused to the ears by the pressured wind that passes by. This project also focuses on reducing road accidents involving cyclists by enabling them to clearly hear everything that is going on in their surroundings. The next purpose of these spectacles is to provide a stylish yet safe and comfortable way to travel on a bicycle. This project also targets to recruit more citizens to travel safely in bicycles without having to worry about the consequences. This project aims to provide a different approach in handling the wind noise problem faced by cyclists while cycling, a solution which they themselves prefer. By recruiting more cyclists, this project hopes to reduce the pollution caused by motor vehicles to the environment. Recyclable items will be incorporated while designing this project. After doing thorough research, we have learned more about our wind noise reducing spectacles. This is crucial in initiating stage to learn and solve the problems using the most effective method. The raw components used to make this product in completion require strength, flexibility, stability, and it's supposed to be light. Therefore, the following are some raw materials we have decided to incorporate to build this model. Aluminium is a lightweight product which is able to withstand direct wind force when connected in a proper manner. It is less dense but has high stability, used as the plates to prevent the wind noise from reaching the ears in this project. Rubber is a sound insulator, a strong product which is malleable and can fit into spaces. For instance, the rubber sheet is cut into slices and is used to fit in between the aluminium plates to deflect the sound and prevent sound noise to reach the ears through the small gaps. Glass, on the other hand, is used to make the lens of the spectacles. Glass is a strong material. Unlike perspex, it is metal coated and would not crack under wind pressure or if it encounters obstacles like little rocks. Carbon graphite is light, can be shaped into an aerodynamic model to fit the needs of cycling going against the wind flow. It is stronger, more durable, and is lightweight. The industrial polystyrene is used as a decent sound insulator. It is used in the industry to absorb sound. The polystyrene is used at the front side of the frame to block the wind noise from directly entering via the face and the front of the spectacles. These are the materials we have decided to incorporate to form our desired model. Our model design works on a concept based on the Bernoulli's principle. When the wind noise reducers, which are integrated with the side frame of the sunglasses, descends and turns to block the direct flow of the airflow of a higher pressure deflects to the outside part of the wind noise reducer, resulting in a lower pressure region at the ear area. This way, the ear is safe from the high pressure from the direct air contact, therefore preventing chances of hearing disorder. It also creates a space or vacuum for clearing hearing of the cyclist to concentrate on the sounds of the environment and maintain safety. Therefore, as initial steps, we have decided to 3D print the wind noise reducer spectacles to test out the functionality of our design. Our expected completion of this project is an estimated duration of 14 weeks. The project sponsorship are the financial and technical support received by a sponsor in order to carry out the project. The companies which have sponsored us will include Taylor's University, whom have sponsored RM500, Camco Aluminium, whom have sponsored aluminium worth of RM200, and PM Net Consultancy, whom have sponsored RM100. We have used the sponsorship to purchase the aluminium, glass, rubber, and carbon graphite, and we have also spent it on other external expenses. This project wouldn't be complete without the support of external parties and people. Stakeholders are the parties whom are affected with the outcome of this product depending on the type of interest shown. The major stakeholders in this project are associations such as the British Cycling Association and Bike Hub, suppliers whom are the Taylor's University and online websites, the board of directors whom are the School of Engineering Dean and Associate Professors and Supervisors, the support staff whom include cyclists and senior citizens, client competitors, namely the carriers, and the end user whom are the cyclists and athletes. The budget for this project was estimated to reach a value of RM400. Therefore, it has become our priority to keep the budget cost within the range provided. After thorough research done on the prices of materials from different suppliers, we have decided to purchase our required raw materials from trusted suppliers, keeping the cost within our budget range at a total cost of RM238. Our priority checklist is still intact as we are still on track with the schedule as planned, keeping our budget cost within the required range of price with the desired quality. Although we have had multiple constraints with the budget and timing, we have still managed to remain on track with the scope of this project. The most important part of a project is to plan the project well before working on it. Incorrect planning may only delay the progress of the project, resulting in the lagging of schedule, and may also cause over-budgeting. There are multiple ways to plan a project well, and the following are some of the project planning methods we have utilized for an efficient working project. Firstly, to learn further about the project, a work breakdown structure is needed. This way, we can estimate the workload allocated in the project and plan how to overcome it. The workload of the project is divided into 4 different sections, namely design, where the design of the project is learned. Materials should be learned in order to determine the type of product to be designed. The prototype, outcome, and the product should be given wise thought to obtain an overview of the product. The Gantt chart is created to create an organized planning of the project. However, the linear responsibility chart is crucial to divide the workload among group members to obtain efficiency in the project progress and to keep track on the duration planned. The SMART principle, such as the specific, measurable, achievable, relevant, and time-oriented element, is obeyed in the execution planning of the project. At this point of time, we are still lagging from our planned dates due to clashes of time and little conflicts in the work allocation. We are still designing and remodeling the prototype at the current stage. Where we plan to be is to have a complete working prototype which can be evaluated. We can still get back on track by readjusting the current prototype to a working model with the cooperation of the group members. Every project is considered successful when it covers the 3 main criteria, which are time, cost, and quality. A given project should be completed within the time frame given, not exceeding the budget that has been drawn and having the finest quality that satisfies customers. There are also the other factors that contribute in the making of a successful project, like the principle of golden circle, that starts with the smaller circle and then goes why, then how, and the bigger circle consists of what. The most fundamental understanding of this golden circle is that if we invent something, it's because of why we do it and not what we did. People are more interested and concerned on the motive of an invention of the object, not blindly purchasing a product for the sake of owning it. With these principles in line, we hope that the outcome of this project will be popular amongst professional cyclists. So we came up with this project because we believe that we can challenge the readily available spectacles in the market by redesigning it in a way that cyclists will now feel safer and comfortable while riding a bike. We have a specific motive that is protection and improve the cyclist's performance. Moreover, in the process of redesigning a product, the main aim is to actually improvise and increase the original features to a better and more high-tech prototype. We believe that our project has covered all the following aspects in order to be feasible in the market, the most favored and purchased item amongst professional cyclists. Overall, I implied that my team has done a great job in cooperating and forming a cohesion among the team members without any personal conflicts, making the task easier. Although there had been some delay in the project, the allocation of workload has been pretty efficient, as we are only closing in on completing our project within our desired duration. The team has built a lot of character along the journey of this project, and hopefully this project turns out to be a success as planned.